Okay, so recording is going. Do you guys have any questions out of the packet from yesterday that you want me to go over? No, sir? Okay. If you guys get a chance, just compare with each other, make sure you got the same answers. If you have any that are conflicting, let me know. We'll go over them for you. So anyway, we were talking about basic circuits. And we left off last time. We had looked at a series circuit. Just a simple 2-resistor series circuit. And let's give it a 120 volt power source here. I realize I used the wrong voltage source symbol if this is AC, but that's okay. For AC, of course, it would be the sine generator. And let's say that this circuit, we have 30 ohm and 10 ohm resistors. I want you to find the current and the total power produced. So what do we need to know before we can find the total current? Total resistance. Of course, we do that by doing what? It's series, so yes, we just add them together. 30 ohms plus 10 ohms, of course, is 40 ohms. So then to find the total current, you got voltage equals current times resistance. So 120 equals I times 40. You divide by the 40. Perfect. So 3 amps equals our total current. So then the power is found by doing what? Amps times volts, current times volts. So 3 amps times 120 volts, which is 360 watts. Now, to get the power dissipated in each resistor, I probably butchered the spelling there, but basically the power that's used up in each resistor. It's the same formula. Power is current times voltage. What do we know about the current in each of these resistors? Well, it's series, so the current has to be the same. So it is 3 amps in each of them, period. What changes is the voltage drop. Resistor 1, we'll call that voltage drop V1, and resistor 2, we'll call that voltage drop V2. A series circuit, the current has to be the same. The current is constant. What is split up is the voltage. That's why a series circuit is often called a voltage divider. Do you guys use that terminology at all? No? I just don't remember it either way. Okay. It's a voltage divider. So the voltage is divided up by your ratio of resistances. But the easiest way to go about it, since we have the current and the resistance, what is 3 amps times 30 ohms? That's 90 volts. How about 3 amps times 10 ohms? What's 3 times 10? 30 volts. So notice 90 and 30 add up to 120. So that's our total voltage. So our power dissipated is current times voltage. 3 amps times 9 volts, or 90 volts, is 270 watts across R1. That would be P1, the power dissipated on resistor 1. P2, the power dissipated on resistor 2. What's the current? 3 amps. What's the voltage? 30 volts. 3 times 30 is 90 watts. That's P2. Notice 270 and 90 add up to our total of 360. You'll notice here the ratio of voltages is equal to the ratio of resistances. 30 ohms to 10 ohms is equal to 90 volts compared to 30 volts. It's a 3-to-1 ratio. Maybe more useful is the ratio of resistance to total. The total resistance here was 40. Resistor 1 is 30 ohms out of a total of 40. So its voltage out of a total of 120 volts ends up being 90 volts is the voltage drop. Does that make sense? So let's say we've got 120 volts here. I am going to tell you that this is an 18 ohm. I'm not going to be that mean to you. Let's call it a 10 ohm resistor. And there is a power loss here. This is R2. So P2 here is 160 watts. Find that current and find what R1 was. Helps if I give you the rest of the information, by the way. I do have to tell you that's a 40 volt drop across there. First thing we need to find is going to be the current. That current right there in red through resistor 2. How do we find that current? Power equals current times voltage. We've got 160 watts times the 10, or not times 10 volts, not 10, but 40 volts. There we go. So we'll divide by the 40 volts. That comes up to be 4 amps is the current. So that's actually got to be our current, since this is a series circuit. That's got to be our current everywhere. So we know that there's 4 amps here. We do also know the voltage drop has to be how much? Got 120 volts here. We've only lost 40. We got to have 80. Good. So we have 4 amps and 80 volts. So voltage equals current times resistance. We put in 80 volts equals 4 amps times resistance, and we will divide by 4. $80 volts divided by 4 amps is 20 ohms of resistance. And of course, the power dissipated there has to be, our total power is 4 amps times 120 volts, so 480 watts. We had 160 here. This has to be 320. I didn't ask you for those other parts, but and all of this could have been solved by ratios. We could have said, this is 40 volts out of a total of 120 volts. It has to be 10 ohms out of however many this has to be. How do we solve that? Cross, multiply, and divide. 120 times 10 is 1200. Volt times ohm is volt ohm. Divide by the 40. Volts, the volts cancel out. That is 30 ohms. That would be, now this is, I should do some labeling here to make this a little more clear. This was the voltage drop across first resistor, or sorry, second resistor. This is R2. Notice those match up, voltage 2 and R2. This is the total voltage. This is the total resistance. When you set up these ratios, everything has to match up. Once we have that total resistance, once we know that that's 30 ohms, we can use it. Now then, we know that the other one has to be 80 volts out of 120 volts. Note again, this is now the voltage on the first resistor compared to the total voltage. Out of 30 ohms, what does that resistance have to be? So again, this is the total resistance. This is going to be R1 that we find. You cross multiply and divide, and we could get the 20 ohms for R2. Any questions on this? Is it all coming back to you? You don't look so sure, Jordan. Okay. You said that little bit of a pained expression. Parallel circuits. In the series circuit, the current had to be the same everywhere, and it was the voltage that got divided. In a parallel circuit, what stays the same? Voltage stays the same. What gets divided? Current. So let's go with a 48 volt DC source here. Let's go with R1 of 16 ohms and R2 of 12 ohms. Is my total resistance 28 ohms? Say no. No. Resistance is a measure of how hard it is for the current to flow. If we go up here to a series circuit, back to the series circuit, if you think of this as being a pump that's pushing water through a pipe, and this is being a turbine or something else that water has to turn, that turbine makes it harder for the water to flow. If I put another turbine or whatever in series with it, does that make it easier or more difficult for the water to flow? More difficult, because it's got to push both of them now, right? In the parallel setup, if I use that same analogy, this is pushing the water flowing through the pipes. If this one weren't here, if it's just this first one, that turbine is making it more difficult for the water to flow. Well, when I open up the second one, this one, the first one is not any more difficult, it's the same difficulty. So the second one makes it easier because there's more options. Even if the second one has more resistance, it's still more options for the water to flow. There's going to be less resistance. So in a parallel circuit, total resistance is always less than either, I'm going to list it as just Rx instead of R1 and R2. The total resistance is always less than any of the single resistors. So the total resistance here will be less than 16 and less than 12. What is the voltage across R1 here? Voltage is just the full 48 volts, right? How about the voltage across R2? 48 volts. Voltage is constant. What is divided is the current. So the current is going to be I1 now and I2. Voltage equals current times resistance. We know that the voltage is 48 volts. We're looking for the current. And I1, what's the resistance? 16. So we divide by the 16. 48 divided by 16 is 3 amps. So that's 3 amps. What do we get for the current in I2? 4 amps. Very good. Because that's just going to be 48 volts equals I2 times 12 ohms. Divided by 12, we get 4 amps there. What does that mean for our total current here? How many amps does that have to be? 7. Very good. I total current has to be the sum of the other currents. Total water flowing has to be the sum of the water through each pipe, right? So to find my total resistance, total resistance is just going to be total voltage equals total current times total resistance. What's my total voltage? 48. What's my total current? 7. So to find my total resistance, I am going to divide by 7, right? 48 divided by 7 is 6.8571429 approximately volts. 285, so it rounds up to 29. How about we go 6.86 ohms? Oh, good question. If I didn't want to go through the currents, how would I find the total resistance? That formula is a shortcut. Only applies if you have two resistors. Okay. What if you have three resistors and well, you're not screwed. There's actually two different ways you can do this. So, let's go 24 ohms, and oh, shoot, let's do 36 ohms. You could combine them two at a time. So 24 times 24 over 24 plus 24, which is 576 over 48, which is what? 12. And then you can take that 12 and combine it with the 36. So 12 times 36 over 12 plus 36. 12 plus 36 is 48. 12 times 36 is 432. Is that correct? Which divides out to be, what, 9 ohms? So you can just apply that formula twice. You combine these two, and then you combine that total with the third one. Or, if you want to do it all at once, it's a reciprocal formula. 1 over RT equals 1 over R1 plus 1 over R2. If it's only two resistors, you can just use this formula right here. If there's a third one, it's R3, or as many as you want. If you have 7 resistors in parallel, you can have all the way up to 1 over R7. You could do 8, you could do 437, however many you want to. What's that? Well, okay. Up to infinity, how's that? Okay. So now we can put in our resistors there. 1 over RT equals 1 over 24 plus 1 over 24 plus 1 over 36. We need common denominator, which is going to be 72. So 372s for 124 is 3 over 72. 1 over 36 is 2 over 72. Three plus 3 plus 2 is 8, so that's 8 over 72. You'll notice that's the reciprocal. So you take the reciprocal. RT is 72 over 8, which is 9. Now you might be looking at that and thinking, well, if I can just do this twice, why would I ever want to do this mess? Because there's a button on your calculator that makes it really easy. You should have the X -1 key. You like that one? The X -1 key is called a reciprocal key. Did Mark show you how to use this one? Okay. So you've got 24 ohms, and 36 ohms, right? So here's what you're going to do on the calculator. You're going to type in 24, then hit that reciprocal key, plus another 24, hit the reciprocal key, plus the 36, hit the reciprocal key. Those are the three resistances. We typed each one in, hit the reciprocal after each one. We hit enter, gives us that total. Now we do the reciprocal key one more time and hit enter, gives us 9. Want me to let you try one? Okay, so let's make this 40 ohms. Let's make this 120 ohms and make this one 30 ohms. See what you come up with for a total. Perfect. Do you torque? Okay. So we're going to back off to just, what's that? Oh, this one's important enough that it's worth it. So let's back off to just two resistors in parallel again. And let's say that this one is, you okay over there? Somebody. They are. Are you feeling bullied and harassed, Ian? Need to go to your safe space? That I can agree with. Find the total power produced and dissipated in this circuit. Of course, first step in time finding total power is to do what? To find the current. And to find the current, you need resistance, right? What's your total resistance? Comes out to be 8 ohms, right? You could do 12 times 24 divided by 12 plus 24. That works. We did 1 over RT equals 1 over 12 plus 1 over 24. It comes out to be 8. You could have also just done, by the way, 48 divided by 12 is 4 amps here. 48 divided by 24 is how many amps here? 2 amps. So our total current has to be 6 amps. Of course, 48 volts divided by 8 ohms would give you a total of 6 amps as well. So then the power is 6 amps times 48 volts, which is 288 watts. Perfect. What if just for fun, well, and part of your grade, what's that? How dare you? A combination circuit, a series parallel. So here we have a series resistor in a parallel resistance in series with a single resistor. What? It's not so bad. Let's give you all the resistances first. I'm going to call this R1, R2, and R3. I want to know power drop across each resistor. P1, P2, P3. First step, let's find the total resistance. Yes, it would, but only for these two, because those two are in parallel. The other one's in series. If I combine the 15 and the 30, what do I get for a total resistance or equivalent resistance? 10 ohms, perfect. Perfect. That is a 10 ohm equivalent to that parallel in series with another 10 ohm. So we get a total of 20 ohms. Now I'm going to pause there. Any questions on that? So what we did, 1 over RT equals 1 over 15 plus 1 over 30, or you did 15 times 30 over 15 plus 30. You got that this section here has an equivalent resistance of 10 ohms. So you can actually take out those two resistors and replace it with a single 10 ohm resistor. Then that 10 ohms is in series with this 10 ohms. So 10 plus 10 gives us a 20 ohm total. So total resistance of 20 ohms, which means total current is how much? Voltage divided by resistance, right? 6 amps. So we know we've got 6 amps here. Now I'm going to pause. Any questions so far? Is there any place in this circuit that has, now I'm going to take out this equivalent resistance right here. Is there any place in this circuit that has to get the full 6 amps? You bet, right there. There's 6 amps there. How many volts is that going to dissipate? Remember, voltage is current times resistance. 60 volts. 6 amps times 10 ohms is 60 volts. So that means from here to here, how many volts are left to dissipate? Yeah, 120 minus 60 leaves us with 60 volts. So there's 60 volts across here. 60 divided by 15 is 4. 60 divided by 30 is 2. Make sure that still adds up to 6, which is true. So now, this power, 60 volts times 6 amps, 360 watts. That's R1, or P1. P2, power dissipated here is 4 amps times the 60 volts across those two, 240 watts. That's P2. And then here, that's 2 amps times 60 volts, 120 watts. That's P3. Add those all up. My total power better be 720 watts. My total resistance was 20 ohms. Well, look at that, 6 amps times 120 volts is 720 watts. I don't have to go the long way to get to it. Does that make sense? Yeah. That's the biggest piece to it, is finding that equivalent resistance. You don't have to find the equivalent resistance for the whole thing at once. You can replace any parallel sections with a single equivalent resistance and then add them up. At some point, I might give you an extra credit question that has, some really weird things like might look like this. Might ask you to find total resistance and total power and stuff and something like that. Obviously, that would be an extra credit question. but it's the same type of thing. You can start in here. Hey, I've got two circuits, two resistors in series. I can add them up. Once I add them up, well, it's in parallel with that one. I can replace that with equivalent resistance. It's always a matter of finding two resistors that you can combine that are either in simple series or simple parallel, and combine them and then replace it with that equivalent resistance. Keep going. Okay. The next thing I want to talk about is cost of power. Anybody know what the current cost per kilowatt hour is? Let's just say it's 14.8 cents per kilowatt hour. To understand what that means, first thing we have to do is define what is a kilowatt hour. A kilowatt hour is something that consumes 1 kilowatt running for 1 hour. So what is your consumed by, the kilowatt hours consumed by a light bulb? Let's say you have a 60 watt light bulb. Now let's look at your average living room light in your home. How many hours a day do you have that light bulb on, that light? 3 hours a day? I can go with that. We're assuming it's a single bulb light. Many of your ceiling light fixtures are 2 bulbs or more. You got a chance, yours is none? Okay. You have a lamp, most lamps are single bulbs. Yeah. So we're just gonna go with a single bulb for now. So 60 watts times 3 hours. That is 180 watt hours. Notice that's watt hours, not kilowatt hours. For a month, let's go a 30-day month. So 180 times 30. That is 5,400 watt hours in a month. How do I change watts to kilowatts? How many watts are in a kilowatt? 1,000. So dividing by 1,000, we just move that decimal point over 3 spots. That is 5.4 kilowatt hours. So your cost, what did I say, 14.8? Yeah. So we're going to take 5.4 kilowatt hours times $0.148 per kilowatt hour. Basically 80 cents a month to operate that light bulb for 3 hours a day. Electric wise, what do you guys think are the most expensive appliance or expensive items in your house to operate? Washer, dryer is actually the most expensive usually. Unless you have electric heat can be pretty expensive as well. A wood stove doesn't take much power. Yeah, if you got electric baseboards, it can be costly. I've known people whose electric bill is like $130 a month, shoot up to $480 in the winter. Electric baseboards, the only way they're really efficient is if you have the off-peak power and you run them from like 7 at night till 7 in the morning or whatever the hours are for the off-peak. And then you leave them off during the day. So anyway, let's look at a dryer. How many loads of laundry does an average family do in a week, do you think? 2? Well, I do 1 load of laundry by myself. So if you have a family of 4, 3 or 4, let's go 3. So a dryer runs for about an hour and 15 minutes. Let's make it simple. Let's go an hour and a third. The reason I'm saying an hour and a third is because 3 times an hour and a third is 4 hours a week. Okay. A dryer runs on what voltage? It's a 220. Anybody know what current a dryer usually pulls? Ask it next time. The current that a dryer usually pulls. It's usually put on a 20 amp breaker. Usually runs right around 15 or 16 amps. Let's go 15 amps. So 220 volts times 15 amps is 3,300 watts. I am going to take our 4 hours per week times 4 weeks in a month to get 16 hours per month. I am going to convert, our 3,300 watts to 3.3 kilowatts. Then I'm going to multiply 3.3 kilowatts times 16 hours gives us perfect 52.8 kilowatt hours. So the cost is 52.8 kilowatt hours times 0.148, which is $7.81, we'll call it. So about $8 a month to run your dryer. It goes up a little bit if you don't clean out your lint vent and stuff, your vents and stuff, if you get clogged up with lint. Or if the kids, what's that? Okay, that's good, probably a good idea. Okay, we'll go with that. It probably costs about, looking here, they're running this 16 times a month. It costs about 50 or 60 cents a shot every time you run your dryer as far as electricity. So I'm going to give you another worksheet on cost of power that I want you guys to look at for tomorrow. I realize I cut it a little bit close to the end of class here today as far as homework. You have the packet from yesterday. Actually, from Monday, I should say. Some people put a capital M on Monday. I want you to finish that. You got this new worksheet that I just gave you, the parallel and series circuit worksheet. I'm going to have you work on that. Then I'm going to give you another worksheet on the cost of power. I'm going to have you do that. The reason I'm loading you down so much is tomorrow you guys are combined with Woods. So when they come in, since their first class was supposed to be on Tuesday and they haven't met with me yet, I'm going to give you guys about 10 or 15 minutes to go over this work. You'll finish these worksheets. So if you guys want to gather together and work on them there in that section by yourself, you can work on them. I'm going to get them started on some stuff, and then I'm going to jump back to you guys and go over these worksheets, and then I'll give you a quiz. Thursdays are going to be a heavy quiz day for you guys, just because. What's that? Do the quiz on Friday. Because you guys are combined with the other group on Thursdays, there's going to be a lot of Thursdays that I give you guys a quiz. I might even try to time most of your unit tests to be on Thursdays so that I can give you guys some time in class to work on them while I'm working with them, and then turn you loose to finish them over the weekend. But I'll get you that other worksheet here.